On April 6, 2026, 4 astronauts aboard a spacecraft named Integrity flew around the far side of the moon and saw things no human being has ever seen. They spent 7 hours documenting craters, ancient lava flows, surface fractures, color variations, and a solar eclipse from outer space. And what they reported back to Earth has scientists rethinking what we know about the moon and what it means for our future there. So let's start with what those astronauts actually saw when they circled the moon. For the first time in over half a century, 53 years, that is how long it had been since a human being traveled to the moon. Artemis II was a crewed lunar flyby mission launched on April 1, 2026, the first crewed flight of the NASA-led Artemis program, and the first crewed flight beyond low Earth orbit since Apollo 17 in 1972. NASA astronauts Reid Wiseman, Victor Glover, Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen were aboard, and the Orion spacecraft, named Integrity, splashed down on April 10th in the Pacific Ocean off the coast of California. The 10-day mission lifted off at 6:35 p.m. from Kennedy Space Center. By day 5, the spacecraft had officially crossed the threshold of the lunar sphere of influence, the point in space where the tug of the moon's gravity becomes stronger than Earth's. And then came day 6. The momentous day began at 1:56 p.m. EDT as the 4 astronauts set the record for the farthest distance from Earth ever traveled by any human, surpassing Apollo 13's distance of 248,655 miles. They splashed down having flown a total of 694,481 miles, with their lunar flyby taking them farther than any humans have ever traveled before, surpassing the previous distance record set by Apollo 13 astronauts in 1970. But the distance record was not the headline. What the crew saw during those 7 hours around the moon, that was the headline. During the lunar flyby, the crew documented impact craters, ancient lava flows, and surface fractures that will help scientists study the moon's geologic evolution. They monitored color, brightness, and texture differences across the terrain, observed an Earthset and Earthrise, and captured solar eclipse views of the sun's corona. The crew also reported 6 meteoroid impact flashes on the darkened lunar surface. During their April 6 lunar flyby, the astronauts captured more than 7,000 images of the lunar surface and a solar eclipse. The imagery includes striking views of Earthset and Earthrise, impact craters, ancient lava flows, our Milky Way galaxy, and surface fractures and color variations across the lunar terrain. 7,000 images, color observations called out in real time, impact flashes documented live. And the crew did all of this while working directly with scientists on the ground at Johnson Space Center in Houston. NASA scientists had identified about 35 geological features for the crew to observe, and working in pairs, the astronauts took photos of the sites and described them in real time to scientists at Mission Control. Artemis II had 10 science objectives for the flyby. One was to observe color variations on the lunar surface. According to Kelsey Young, the Artemis II lunar science lead, the human eye, especially when it's connected to a well-trained brain, which I assure you these 4 people have, are capable of just, in literally the blink of an eye, making nuanced color observations. That idea that what these astronauts could see with their own eyes would matter more than what orbiting cameras had been collecting for decades is the foundation of what happened next. The satellites and orbiters had given us maps. The Artemis crew gave us something different. They gave us perspective, and that perspective changed the conversation. When Orion swung around the far side of the moon, one of the first major targets on the observation list was a feature that had never been seen in sunlight by human eyes. The Orientale Basin is a 600-mile wide feature known as the Grand Canyon of the Moon. Human eyes had never seen Orientale in sunlight before, so the Artemis science team asked the astronauts to observe it very thoroughly, and they did. NASA said the Artemis II crew was the first to see the entire basin. Up close, Mission Commander Reid Wiseman described its annular ring, one of the basin's key aspects. The annular ring, which I think everybody describes as a pair of lips or a kiss on the far side of the moon, from here is very circular in nature. He went on to say the northern part of it was wider and darker, while the southern part was much lighter, and that it was far more circular than I remember it looking in our training. Now, let's understand why this matters. the astronauts focused some of their observations on the Orientale Basin, a nearly 600-mile-wide crater that straddles the moon's near and far sides. The 3.8-billion-year-old basin was formed when a large object smacked into the moon's surface. The crew's high-resolution photos of features in and around the moon's impact craters could help scientists understand how the moon formed and how its topography changed over time. This is a crater system so large, so well preserved, and so positioned between the near and far sides of the moon that it has been a geological puzzle for decades. From Earth, we can only see a sliver of it. Satellites have mapped it, yes, but two-dimensional data can only tell you so much. What Wiseman was describing, the relative brightness between the northern and southern portions, the circularity of the ring structure, the texture shifts between sections. That is the kind of nuanced, real-time observational data that has eluded the scientific community. Mission scientists were thrilled as the astronauts reported seeing variations in color in the different parts of Orientale and in other regions, including many shades of brown as well as some greens on the moon. Mission specialist Hansen described one plateau as having unique greenish hues and said, "I didn't see anything like that anywhere else on this side of the moon." The significance of color observations on the lunar surface cannot be overstated. Artemis II had 10 science objectives for the flyby. One was to observe color variations on the lunar surface. Changes in color can indicate the composition of the minerals on the surface, and these changes are hard to detect with satellite images. Shades of brown can indicate different types of regolith. Greenish hues could suggest different mineral compositions or ages of exposed material. Every color nuance the crew called out potentially points scientists toward a better understanding of how the moon's surface has been shaped over billions of years. And then there was the moment that stopped everyone, astronauts and mission control alike. The astronauts also spied rings around the Orientale Basin. Prior to this mission, Orientale had never been seen with human eyes before. At the 10 o'clock position in relation to Orientale were two small craters. The astronauts suggested naming one Integrity for their Orion spacecraft, and the other Carol for Artemis II Commander Reed Wiseman's late wife. Carol Taylor Wiseman, a nurse in a newborn intensive care unit, had died in 2020 following a battle with cancer. After naming the crater Carol, the four astronauts hugged while shedding tears, and a moment of silence was observed in NASA Mission Control in Houston. A man traveled 252,756 miles from Earth, saw something no human had ever seen, and named it after the woman he lost. That moment alone underscores why human exploration matters, in ways that no robotic orbiter can replicate. Science and humanity tangled together on the far side of the moon. But Orientale was only part of the story. The observation program included another feature that may prove to be the most consequential target of the entire flyby. The astronauts also got looks at parts of the South Pole Aitken Basin, one of the most dramatic features on the moon. It is the largest confirmed impact crater in the solar system, stretching more than 4,550 miles from rim to rim. And the South Polar area is of great interest to scientists and Artemis mission planners, as the region is thought to harbor large amounts of water ice on the permanently shadowed floors of many of its craters. This is the crux of the changes everything part of this story. The entire Artemis program, every future mission, every plan for a lunar base, every roadmap to Mars, all of it hinges on what exists at the moon's south pole. And what is believed to exist there is water. In 2020, NASA announced the discovery of water on the sunlit surface of the moon. Data from the Stratospheric Observatory for Infrared Astronomy, SOFIA, revealed that in Clavius Crater, water exists in concentrations roughly equivalent to a 12-ounce bottle of water within a cubic meter of soil. Across the lunar surface, the discovery showed that water could be distributed across the lunar surface, even on sunlit portions and not confined to cold, dark areas. Let that sink in for a moment. A 12-ounce bottle of water locked inside a cubic meter of lunar dirt on the sunlit side of the moon. Now imagine what might be hiding in the permanently shadowed craters of the South Pole, where temperatures plunge hundreds of degrees below zero, and sunlight has never touched the ground. A study by scientists from PRL and IISR in 2026 postulated that water ice deposits in the moon's south polar regions, where craters remain in almost constant darkness and temperatures plunge below -160 degrees Celsius, are far more stable than previously believed. offering a major boost to future human exploration plans. The implication is staggering. These deposits may have sat accumulated and undisturbed for perhaps billions of years. The Artemis II crew documented the topography along the terminator, the boundary between lunar day and night, where low-angle sunlight cast long shadows across the surface, creating illumination conditions similar to those in the South Pole region, where astronauts are scheduled to land in 2028. This is critical. The crew was essentially scouting the lighting conditions that future astronauts will face when they actually touch down on the South Pole. Kring, who gave basic training to all 4 astronauts, has been working for years to explain the dramatic elevation of features on the Moon's South Pole. The elevation changes are greater than the elevation of Mount Everest on Earth, he said. Mountains taller than Everest, craters that have been dark for billions of years, ice deposits that could hold the key to sustaining human life off Earth. And the Artemis II crew just got the first direct human look at this landscape. They captured images of the South Pole Aitken Basin that, combined with their real-time verbal descriptions of color and texture and topographical relief, will reshape how NASA selects its landing sites for the missions that follow. Beyond its resource potential, the South Pole Aitken Basin is a geological treasure trove because the impact that formed it excavated deep into the lunar crust and possibly into the mantle. It offers scientists a rare opportunity to study material from the Moon's interior without drilling. By analyzing rocks and regolith in this region, researchers hope to better understand how the Moon formed, how it cooled, and how its internal structure evolved over billions of years. With a diameter of 2,500 kilometers, it is the largest impact crater that we know of in our solar system. The crater penetrates deep into the Moon's crust, right down to the mantle below. The basin is so deep that it has exposed a variety of different rock layers, providing a perfect timeline of how the Moon formed and changed over time. This is not just about finding water. This is about reading the Moon's biography, written in its own rock. Toward the end of the 7-hour observation period, something extraordinary happened. Something the crew had trained for but could never have truly prepared for. The Artemis II crew captured an image of the Moon fully eclipsing the Sun. From the crew's perspective, the Moon appeared large enough to completely block the Sun, creating nearly 54 minutes of totality, and extending the view far beyond what is possible from Earth. A glowing halo appeared around the dark lunar disk. The science community is now investigating whether this effect is due to the corona, zodiacal light, or a combination of the two. 54 minutes of totality. On Earth, a total solar eclipse lasts a few minutes at best. From beyond the Moon, the Artemis II crew watched the Sun disappear and reappear over the course of nearly an hour, and the scientific questions it raised are still being debated. The astronauts had a rare opportunity to observe a solar eclipse from the opposite vantage point. Watching the Sun disappear behind the Moon, the roughly hour-long phenomenon allowed the crew to study the solar corona, the Sun's outermost atmosphere. It's truly hard to describe, Glover said of the eclipse. It's a wicked view. Commander Reed Wiseman put it even more plainly. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window. That glowing halo the crew documented. The one scientists are debating the origin of is itself a significant observation. If it is entirely the solar corona, then the crew has delivered the most prolonged and detailed human observation of the Sun's outer atmosphere in history. If part of it turns out to be zodiacal light, the faint glow caused by sunlight reflecting off interplanetary dust, that opens an entirely different line of inquiry about the material that surrounds our inner solar system. The Artemis II crew used eclipse viewers to protect their eyes at key moments during the solar eclipse. This was the first use of eclipse glasses at the Moon to safely view a solar eclipse. Eclipse glasses at the Moon. A sentence that would have sounded absurd 5 years ago. But the eclipse also provided an unexpected bonus. During the eclipse, the crew had an opportunity to look for some rarely seen phenomena that are only visible on an unlit portion of the Moon. They reported 6 light flashes created by meteoroids impacting the lunar surface. While traveling many thousands of miles per hour, scientists are already looking forward to the images. After the lunar data is downlinked from the spacecraft overnight, scientists will look at images, audio, and other data to determine better times and locations of the flashes and seek input from amateurs who were observing the Moon at the same time. 6 meteoroid impacts seen in real time. These flashes tell scientists how frequently the lunar surface is being pelted by space debris, data that is directly relevant to the safety of astronauts, who will eventually live and work on that surface. If the bombardment rate is higher than models predict, it changes how habitats are designed, where they are placed, and how exposed astronauts can be during surface operations. Toward the end of their lunar flyby, the astronauts became the first to witness a solar eclipse from space. They made detailed observations over the course of about an hour, as the sun slipped behind the moon and re-emerged again on the other side. During the early stages of the eclipse, the astronauts had to don special glasses to protect their eyes until the sun's light was fully blocked. In one of the eclipse images, bright points of light were visible around the edges of the moon. Those spots turned out to be planets, including Saturn, Mars, and Venus. Saturn, Mars, and Venus, all visible from behind the moon during a solar eclipse. That is the kind of image that changes the way an entire generation thinks about our place in the solar system. So where does all of this lead? The observations, the 7,000 images, the color data, the crater documentation, the eclipse science, the meteoroid flashes. What does it all build toward? NASA Administrator Jared Isaacman described the Artemis II moon mission success as just the start of a relay race to the moon that will eventually lead to a landing, a moon base, and more. NASA has said observations during the Artemis II mission could be used to pinpoint possible landing sites for missions to come. That is the immediate practical application. Every photograph of the Terminator line, every description of surface texture, every observation of the South Polar craters, all of it feeds directly into the selection of where the next crew will actually set foot. In late February 2026, NASA expedited Artemis III to 2027, but it would no longer land on the moon. Instead, it would conduct rendezvous and docking tests in low Earth orbit, with one or both commercially developed lunar landers, SpaceX's Starship HLS and Blue Origin's Blue Moon, and test the new Axiom Extravehicular Mobility Unit spacesuit. The plan now calls for Artemis 5R astronauts to travel to lunar orbit, where 2 crew members will descend to the surface and spend approximately a week near the south pole of the moon, conducting new science before returning to lunar orbit. That is the mission where humans will actually walk on the South Pole. And when they do, they will be carrying instruments specifically designed to hunt for what the Artemis II crew glimpsed from orbit. The Lunar Microwave Active Passive Spectrometer, or LMAPS, will help define what is below the moon's surface and search for possible locations of ice. Containing both a spectrometer and a ground-penetrating radar, the instrument suite will measure temperature, density, and subsurface structures to more than 131 feet below the surface. Scientists still do not do science splin like lack Wah. Ice-rich comets or drier asteroids are the two prime suspects. Geochemical studies of various meteorites and Earth's oceans hint at asteroids as the more likely culprit. But the case is far from closed. And because Earth and the Moon share a very similar ancient history, the origin of water on the Moon is likely the same as the origin of water on Earth. Think about that. Finding and characterizing water ice on the Moon does not just tell us about the Moon. It potentially tells us about where the water in our own oceans came from. The answer to one of the most fundamental questions about life on Earth might be sitting in a permanently shadowed crater at the lunar South Pole. The prospects for sustained human presence on the Moon have been enhanced by the relatively recent discovery that the Moon harbors water in the form of ice, which could be used not only for drinking and irrigating crops, but also for producing oxygen and making rocket fuel for future flights. Water for drinking, water for growing food, water for oxygen. Water for rocket fuel. The Moon is not just a destination anymore. It is a potential supply depot for deeper exploration of the solar system. The long-term goals of the Artemis program include establishing a permanent human presence on the Moon, building the Lunar Gateway space station, and preparing for future missions to Mars. What the Artemis II crew found, or more precisely what they confirmed, documented, and saw with their own eyes for the first time, accelerates all of this. The images of the Orientale Basin reshape our understanding of crater formation. The color observations hint at mineral diversity we did not fully appreciate. The documentation of the South Polar terminator conditions gives engineers real data for lander design. The Eclipse observations open new avenues of solar and planetary science, and the meteoroid impact flashes provide critical safety data for surface operations. Science officer Dr. Kelsey Young summed it up when she told the crew after the flyby, "I can't say enough how much science we've already learned, and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today." The Artemis II crew did not walk on the Moon. They did not collect samples. They did not plant a flag. What they did was circle it, look at it with human eyes, describe what they saw, photograph what they could, and hand a scientific community starved for direct human observation the most detailed first-hand account of the lunar surface in over 50 years. They saw a crater no human had ever seen. They watched an eclipse from a vantage point no human had ever occupied. They spotted meteoroid impacts happening in real time. They documented terrain that will determine where the next generation of lunar explorers will live and work. And all of it, every image, every observation, every color description, every moment, points to the same conclusion. The Moon is not the barren, dead world we once thought it was. It is an archive of our solar system's history, a reservoir of resources that could sustain human life, and the launch pad for everything that comes after. What the Artemis astronauts found changes everything, because it confirms that going back was never just about nostalgia. It was about survival. It was about the future, and that future just got a lot closer.